Hello and welcome to this tutorial on how to model your flan blade for ETEC 246. What you see in front of you is a sample drawing for that fan blade, and you only have to model a flat version of the blade. You don't have to model the blade with the blades twisted. If you look at this drawing here, you'll see that a couple of things you have to pay attention to. One of these is that the gap between the leading edge and the trailing edge, as is shown here in this detail, there has to be a gap or a straight line. I recommend that you use 10,000ths of an inch. Here's the detail down here on the front view of the blade itself. So you have to have this gap, otherwise the water jet is not going to be able to get in there and cut properly this leading edge or trailing edge on the leading edge of the next blade. So this here is a sample. I'm going to switch over and show you the constraints that are given. So you're going to have to keep your blade within a 4-inch square, so your maximum diameter is 4 inches. On the center, you're going to have to cut a hole out, which is 0.825. This diameter is selected so that the bushing that we use can fit into the blade. When you cut your blades, you need to make sure that they do not get any closer than 1.2-inch diameter from the center. The reason being that if you get closer than this circle here, this dashed circle, is when you twist the blades, the aluminum, which is relatively soft, may tear. So that's another constraint. So these are the constraints that you have to work with. Also, if you look up here in the top right hand corner, in order for it to function properly, you need to have odd blade count. You should not have less than 7 blades and no greater than 15 blades. It's up to you if you want your sprinkler to function. If you don't want it to function, then of course you can play around with this a bit, play around with your design. But if you want it to function, you need an odd number. And regardless of what you do, you should not have less than 7 blades. That's one of the requirements for that you'll be evaluated on. What you need to do is print out a drawing at the end when you're completed that looks similar to this. So you have to create a dimension drawing with a frame and title block, as is shown down here, and dimensions similar to this. And then you also need a DXF file that has basically the boundaries of the blade, so the outer boundary as well as the circular inner boundary. This DXF file is what's used to drive the water jet. So let's look at how we go ahead modeling the blade. So I'm going to switch over to CATIA, and I'm going to go and create a new part. I'll just call it fan blade. Always make sure that your units are properly set. I'm just going to check and make sure that my units are set to inches. I do believe that they are. So under the options menu, if you go to parameters and measure, the units tab, just confirm that your units are inches. That's the case here, so I'm going to hit OK. Since this is a 2D shape, you can just go ahead and sketch right away on one of the primary sketch planes. I'm going to use the XY plane and go ahead and create a sketch. Notice too that the grid should have also been set up. My grid is set so that each of the major divisions is 1 inch, and so the smaller divisions is 100 thousandths or 1/10 of an inch. I'm going to start off by using construction geometry. So I'm going to go over to the Sketch Tools toolbar, and I'm going to activate my construction geometry tool so that I can draw in some of the constraints. So the first one I'm going to do is the outer boundary of the blade, which is of course a circle, and the diameter of that is going to be 4 inches. So I'm going to change this to 4. So that's my outer constraint. I'm also going to model a blade. I'm going to use the top right hand quadrant here. So I'm going to draw some construction lines just to kind of give me a guideline of where the blade boundaries are going to be. So I'm going to draw this vertical line here, and then another construction line. I'm going to use 9 blades. So what I want to do is ensure that the angle between these two construction lines is going to be 9 into 360, which is 40 degrees. So here's the angle, so I know that the blade that I'm going to draw is going to have to lie within this segment of the circle. I'm going to turn off construction geometry now, and I'm going to draw the center circle. And of course that is going to be 0.825. And I did forget that circle that determines the closest that the root of the blade can get to the inner circle. So I'm going to turn back on my construction geometry again and draw that circle. So let's go ahead and draw that circle here. And the diameter of that circle is going to be 1.2. There we go. So we have some construction geometry set up. Now I'm going to go ahead and start sketching my blade. I'm going to zoom in a bit. Turn construction off. I'm going to go ahead and use the profile tool. I'm going to sketch the blade assuming that it's pretty much a simple shape. I probably put some corners on them, on the edges of the blade. Let's go ahead and start by, I'm going to use the root circle, sketch a line. Notice that I'm sketching the line slightly off the construction line that I sketched vertically, and I'm going to sketch it between the inner root circle and the outer edge of the blade. I'm going to hit escape. Sorry, I'm going to have to repeat that. I'm going to just use the line tool. And I'm going to do the same thing over on this side. Notice that the parallelism constraint comes in. You can see it in this area here. There it is. I don't have to put a parallelism constraint on this first line because it is vertical, which is the same as the construction line that I drew previously. Now, because I want the gap of the blade to be 10 thousandths, I'm going to dimension from the vertical to this line using my dimension tool. I'm going to dimension that to 5 thousandths. And I'm going to do the same thing on this side here. Now, it's obviously hard to see that gap. You'd have to zoom in quite a bit to sort of see it. There we go. I'm now going to draw the arc that connects the end point of the leading edge of the blade with the trailing edge. So I'm going to go over to my arc tool. I'm going to use the last tool on the toolbar, the arc tool. Pick the center of the arc. Let me zoom out a bit. And I'm going to pick the end of the line and drag the arc over to the end of the trailing edge. You may want to zoom in and be sure that you pick those points. As you can see here, snap right onto the end point of the leading edge, and the same thing should be true on the trailing edge. And actually you can see here that I did miss. Notice that there. So I'm going to use the trim tool and just make sure that I get it where it needs to be, because if it's not there, then I'm going to have problems when I try to pad the profile or when I duplicate the profile around. So these are the primary edges of the blade. I'm going to come in here and now draw the line segment that's the root. So the way I'm going to do this, zoom in a little bit more. I'm going to draw a line from here over notice that there is a tangency constraint. I don't want that, so I'm going to make the line at an angle. And the reason why I'm doing that then is because I can use a perpendicularity constraint. Well, there are a couple of ways of doing this. Another way to do it is to make this endpoint coincident with the arc. So let's try it that way. And then force this to be horizontal. So this line now is 10 thousandths of an inch in length. Now, do I need to do this also on the other edge of the blade? I don't, because the idea here is that I'm going to copy this geometry and rotate it. So this point here, when I make a copy and I rotate it, should connect up with this point over here. And the idea being that once I copy this shape around 9 times, I end up with a pattern that completely, a blade pattern that completely covers the entire 360 degrees of the fan blade. So let's go ahead and do that. If you want to, you can of course put, let's say we wanted to round the edge of the blade. I could do that now using the fillet tool. Well, let's go ahead and do that just to show you a little bit of extra capability. The other way to do it, of course, is to wait until you've created the solid pad and then use a round feature or fillet feature. But let's go ahead and add our fillet here. Let's say we want to make this 0.25, and let's do the same thing over here on this side. And 0.25. So we have 1, 2, 3, 4, 5, 6 pieces of geometry, 4 lines and 2 arcs that make up the profile of a single blade. And now I'm going to use the rotation copy tool, which is on the operations toolbar. If I move over here, there's the rotate tool, which also allows me to copy at the same time, and I'm going to use that to create 8 additional copies of the fan blade. Okay, so to do the patterning within the sketch, or the copying within the sketch, of course another way to do it too is to model a single blade as a pad and then use the patterning, circular patterning tool on that feature. But we're going to go ahead and just copy this geometry on the sketch. You've probably done this in your earlier intro to CAD class, but just to refresh your memory, let's do it here again. So what I'm going to do is pre-select the geometry I want to copy. I'm going to have to zoom in a bit so I can grab this line here. There you go. I'm going to pick this vertical leading edge. I'm going to zoom out now a bit. The computer's a little bit sluggish. I'm going to grab this corner, the outer boundary, circular boundary. There we go. Second corner. Again, things are a little sluggish. And the trailing edge of the blade. And now I'm going to use the rotate tool. So it asks me the number of instances. Since I already have one instance, I'm going to type in 8. I'm not going to do constraint conversion, so the resulting copy, entire fan blade, is not going to be fully constrained, and that's okay. We can live with that. Now, in order for me to do this, I'm going to have to pick the center of rotation, which is the center of the fan blade, and I'm going to establish a reference. It's easiest to use the vertical as the reference. And now as I move my mouse to the right, you can see the instances of the fan blade being created. Now at one position of the mouse, you'll notice that the angle over here shows 320 degrees. You could also move the mouse all the way over to the left-hand side, and you will find there's a position at 40 degrees, if I can find it now. There we are, where we have all 8 instances plus the original 9 correctly positioned. So I'm going to just click down, and I have rotated that original image, but at the same time I've created 8 additional instances, as you can see here. You can see that it's not constrained. Again, it's not a requirement for you to go through, and if you approach it this way and individually constrain each one of the blades. I'll let that slip for this assignment. Normally we require you to constrain things, but that's a lot of work in this case. One thing that you should do, it's a good practice, is to check and make sure that you have a proper boundary. It's very easy doing it this way to make a mistake and, let's say, put in 9 instances and have an overlapping instance over the original, in which case you won't be able to pad the blade. So it's a good idea to go in and check using the sketch analysis tool, which is down here on the bottom, that you have just 2 profiles in your sketch. So let's run this, and what you should see is a circle, which is the inner boundary of the blade, and then the outer boundary of the profile, which is a closed curve with 54, a closed boundary with 54 curves in it. Now what can happen easily, as I said, is that you use 9 instead of 8 and you create an overlapping part of the blade. Just to show you what would happen, let's say for example I draw a line and I'm going to overlap it over this, and then let's just delete one of these root lines. So now when you're looking at the blade here, you might think that you're done, and it's very hard to see that you have overlapping geometry, of course, or that something is missing. You might exit from the sketcher thinking that you're done, and then decide to pad this using the pad tool, and you get this message. And basically this message happens when you don't have a properly defined sketch, when you have overlapping geometry or profiles that are open. So let's go back into the sketch. I'm going to just delete the pad. Let's just go back into the sketch. Sorry, let's go back into the sketch. And that's why it's good to use this sketch analysis tool. And now the sketch analysis tells us that we have a circle still, and we have this profile, but it's open because we deleted one of the small root lines. And if you zoom in, you can see where the sketch analysis tool shows you the gap. So we can see there's a gap there that we have to fix. And it also shows us this isolated line. This was the line I drew over an existing line. So what I can do is I can delete this, and there's a tool down here, these corrective actions, that allow me to delete this geometry. So now I've solved one of the problems, and the other problem is to close open profile. So if I hit close open profile, well, looks like that didn't work very well in this case. It did a solution that I don't like, so I'm going to undo that, go back into sketch analysis. So Control Z undid it. I'm going to again delete this. So the corrective action tool doesn't help in this case, but it's relatively easy to fix now that I know where the gap is. I can zoom in and just draw a line connecting these 2 points. And again, for good measure, run the sketch analysis tool just to make sure that we have a nice closed profile. So with that done, I'm going to exit the sketcher, and now if I try to pad, it should pad correctly. Yeah, there we go, no error message. I'm going to pad assuming 1/16 of an inch thickness. And there we go. There is our blade. Now you need to have a pad for the next step, which requires you to do the drawing as well as to do the DXF file. So let's go ahead and do this. I'm going to go ahead and change my workbench over to the drafting workbench. I'm asked to create a layout here, so I'm going to go ahead and just create a empty sheet for now. I'm going to make sure it's an A size. That should be the default. If you want to, you can always modify by clicking the modify button. Actually, it seems as if I'm on B size, so I'm going to switch this to A size. And I'm going to leave it as landscape. Hit OK. Hit OK. And here we have our sheet. So if you want to do a drawing, of course, you've got to put a frame and title block in. Just to remind you how to do this, you have to go to the sheet background, edit, sheet background, go to insert, drawing, frame and title block, and you should have some options here to pick from. Use drawing title block sample 2, hit OK, and you should change this information. You shouldn't leave it as Dassault Systems. You should change it to say ETEC 246. You should put this should have your name, so you shouldn't have to change this. You should put a drawing title number, and be sure to include the units. So in this case it's going to be inches. I'm not going to go through detail. You should remember how to do a drawing from your Intro to CAD class. What I'm going to show you how to do, however, is a DXF file, which is really important for running the waterjet. So I'm going to create a new sheet. I'm going to insert a new sheet. It's going to have the frame and title block. What I'm going to do is go to File, Page Setup. Sorry, I'm going to go back into the sheet background. My fault. And I'm going to go to Tools, Insert, Drawing, Frame Title Block, and I'm going to delete so I've deleted it from this sheet. However, if I go back to sheet 1, notice that the frame and title block is still there. So you'd have to, so that's how you have a frame and title block on one sheet and it clean on another sheet. We want it clean. We don't want anything else other than the profile of the blade. So I'm going to go to my Views toolbar, and I'm going to select Front View, and I'm going to go back to my model, the fan blade, and select the top of the blade, the plane of the blade. I can position it, of course, but this is all I'm going to do. So I'm going to just click down, and there we have our blade. I'm going to delete this text here. Now if I zoom in, you should see that I have a leading edge, trailing edge, and then I have these lines connecting the leading and trailing edge of two successive blades. And that's really all you need for your DXF file. The last thing you've got to do is save it. So File, Save. The type of file that we want to save it as is a DXF file. Notice that the default is CAT drawing. So go ahead and change this to DXF, and then make sure you remove the .cat drawing extension. Give it a proper name, and then go ahead and save it. And then once you have this, you go to Canvas and you upload it to the assignment link. There's a link there that allows you to upload both the DXF file as well as the drawing file. And that's all there is to it. Now, you are required to use CATIA to do your fan blade. We don't like you using other CAD systems because other CAD systems do not generate clean DXF files. Well, I shouldn't say they do not generate. It's that there's certain procedures that have to be followed, and in our experience, most students who try other CAD systems don't know how to do it correctly, and it creates lots of problems for us on the waterjet trying to fix the problems in the DXF files. So you have to use CATIA. As you can see, it just took me 25 minutes to get to this point. Shouldn't take you that long to be able to go through the steps, do the modeling in CATIA, do the sketching, do the padding, and this is all you need to do to create your DXF file. Of course, you've got to do a little bit more work on this sheet here to do your drawing with dimensions. This drawing with dimensions also needs to be uploaded as a PDF file to the assignment link, and you have to bring a hard copy to the lab when you're going to have your waterjet cut. So please remember to do that. So that's it in a nutshell, how to go about satisfying this requirement for your lab assignment.